coordinate plane. Let's get into it. So, the orthocenter is going to be a little bit different than the centroid and the circumcenter in the case where you don't care about the midpoint. We care about the altitudes of the triangle, which the altitudes of the triangle don't go through the midpoint very often. So, we're going to be more concerned with the slope of two sides of this guy, of the triangle, and make sure that they are just perpendicular to that side of the triangle and then go through the opposite angle. So, what that's going to look like is we want to first pick the easiest side. In this case, it's going to be RT, and I am going to want to draw a line that is perpendicular to RT. RT is horizontal, so perpendicular to RT is going to just be straight up and down. But I want it to be straight up and down going through that opposite angle, which is point S. So there's the 90-degree line, and it's going through point S. That altitude is a vertical line. Vertical lines are x equals equations. In this case, it is x equals -2. So we want to get the perpendicular slope to any given side and then go through the opposite point and write that altitude equation. Before I go any further, I want to write down the coordinates of these points. So the coordinate of R was at -8, -2. The coordinate of T is at +2, -2. And the coordinate of S was -2, +6. Okay. So now we have to pick a different point, or excuse me, a different side that we would like to find the perpendicular slope to. So I'm going to just choose ST. It's looking right at me right here. So I'm choosing ST. I'm going to find the slope of ST, and then I'm going to find the perpendicular slope to that. So I'm going to use my slope formula with ST. Y2 minus Y1 would be 6 minus -2 over -2 minus 2. 6 minus -2, -2 minus 2 gives us 8 over -4, which could simplify down to -2 over 1. Perpendicular to that would be 1 over 2. So we have the perpendicular slope of ST. We want to get the equation of the line that is perpendicular to ST but goes through point R. So point R, we're going to try and draw a line that does like this, that happens to be perpendicular to ST and go through point R. So we need the equation of the line that is perpendicular to ST and goes through point R. We're going to have to use the point slope formula. We have our point R, -8, -2, and we have the perpendicular slope. So change the -2 to a minus -2 makes a +2. 1/2 x minus -8 changes to a +8. Distribute the 1/2, y plus 2 would equal 1/2 x plus 4. And subtract 2 from 4 minus 2 on both sides, we get 1/2 x plus 2. Because 4 minus 2 still equals 2. So that right there, ladies and gentlemen, that is the altitude of this line right here that happens to be perpendicular to ST, and it is going through point R. So I was pretty close before. We got the altitude of 1/2 x plus 2. From this point, we want to set these two equations equal to each other and solve via elimination or substitution. In this case, substitution, x equals -2. I can plug in the -2 for x to figure out the y value. 1/2 times -2 plus 2 makes -1 plus 2, which is 1. So we knew our x value. Now we know the y value. We have our orthocenter as -2, 1. Now, if I was looking at my graph, I would have guessed probably -2, and I wouldn't have known for sure if that was up here at 1 or 1.5. I wouldn't have been entirely sure until I set those two equations equal to each other. All right? I'm going to do one more quick example, and then we're going to be done with this video. So this next one, we have to graph the points at -5, 1, 2, 3, 4, 5, -3, 1, 2, 3, and then -5, 5, 1, 2, 3, 4, 5, and then we have 7, -3, 1, 2, 3, 4, 5, 6, 7, -3, 1, 2, 3. So this is looking like it's going to be a right triangle when I look at it. We got two different perpendicular sides here. So I am most likely going to want to use these two sides. And this might actually not be the last problem, because this one's actually too easy. When we think about it, if we wanted to be perpendicular to this vertical side, we would be right here. And if I wanted to go straight to that opposite angle, I would be using this line. And if I wanted to do the same thing over here, this would be the altitude. So actually this side right here is an altitude, and this side right there is an altitude. Well, where do they intersect? Where do these two altitudes intersect? Right here at the corner. So this is just a very awkward, different type of problem where you actually have your orthocenter on that bottom corner. And that bottom corner is a combination of the x equation and the y equation. The x equation was x equals -5, that vertical line. The y equation is y equals -3, that horizontal line. Well, the coordinate point of the orthocenter is going to be at -5, -3. And it is right there, -5, -3. Let's try one that's going to be maybe a little bit more difficult than that. That one was too easy and made it almost to the point where we didn't have to learn anything. Number 8. -7, 10. 1, 2, 3, 4, 5, 6, 7, all the way up to 10. Label that point L. M is at 8, 0. And N is at -3, 0. Now this orthocenter has a chance of being outside of the triangle, so don't panic if that happens. This one might, I'm not sure. But there is a good chance of that happening. Let's label M. Let's label N. Alright. So I am going to now find the perpendicular slope to these guys. And you may want to choose line NM. But you may notice that NM, we can't really go up from there to L. So if you wanted to use it, you would have to extend it out past it. So I would extend this line NM, and then I could draw this altitude that I'm doing in a dotted red line. That altitude is an x equals equation. It's an x equals 1, 2, 3, 4, 5, 6, 7. That is an altitude of x equals -7. I now need to find the perpendicular slope to any of the other sides. I am going to choose LM. LM has a lot of real estate, so I'm just going to choose that one and see how it goes. So LM, I'm going to find the slope of LM, and then I'm going to find the perpendicular slope of LM. So LM, I would have to do 0 minus 10, y2 minus y1, over 8 minus -7 turns into -10 over 15, which simplifies down to -2 over 3. Perpendicular to that would be 3 over 2 when you flip and switch the slope. From here, I have my perpendicular slope. I want to get a perpendicular slope to LM, that goes through point N on the opposite side. So we're looking for something that kind of does that number where it's perpendicular to it and goes through line N. So that means that we need to use our point slope formula, y minus y1 equals mx minus x1, plug in our perpendicular slope, and plug in point N. So y minus 0 would equal 3 over 2, x minus negative 3 turns into a plus 3, plugging in point N. Distribute the 3 over 2, you would get y equals 3 over 2x plus 9 over 2. Okay? From here, now I can actually figure out the rest of this problem by knowing that these are the two equations, setting them equal to each other. Now this one might for the first time be a decimal, but we'll find out. We're going to plug in negative 7. We're going to get y equals 3 over 2 times negative 7 plus 9 over 2, which would be negative 21 over 2 plus 9 over 2. What happens when I add negative 21 and 9? Well, that is going to be 12, negative 12. What's negative 12 over 2, though? Just negative 6. So that is my y value, negative 6, and my x value is negative 7, which means that the orthocenter is going to be on the point x comma y, negative 7, negative 6. That is my orthocenter. And let's see if it looks like I was close when I was drawing my graph. So if I was drawing my graph, I was going and drawing this line right here, and I had my dotted line right there. Where do they kind of look like they intersect? It looks like it intersects at negative 7 and about down there at negative 6. So this isn't that far off when I was eyeballing it with my guess. Negative 7, negative 6, there's the orthocenter. And I was right. It's not inside the triangle. Not all orthocenters will be. That's going to do it for today's episode. Until next time, stay positive, and I will see everybody later.